Greetings, students. Mr. Munir here with your Module 13 test review. Okay, so we've made it through all of our lessons. We've got our test coming up. Now it's time to review. Just a quick heads up before I go into it. How can you find all the review material? Just go to my class, go to topics, and right here, Module 13 test resources. You're going to find the review worksheet that I'm going to be working from in this video. And you are going to find Module 13 videos YouTube playlist that's got lessons 13.1 through 13.3 and also this review video there. So all the videos are there and this is the worksheet. So that's just about everything that you'll need. Other than that, you can always go through the book on my.hrw.com and review that way as well, which I suggest you do. So with that being said, let's jump right into it. In terms of talking about the test. So what's the test going to be like? Well, as I said, it's going to be on my CCA. There's going to be multiple choice questions. There will also be free response questions that I'll be grading. And you will meet on the date of the test and you will go to our Google Hangout. So in order to find our Google Hangout, it's the same one as we usually go to, and that's right here in the topics Google Hangout link. We will go there and you will meet me there. I'll turn on Blocksy. That is when you will do your test. You'll go on my CCA, you'll do the assignment. The test will be released at the time that we're meeting, and you'll take the test. I'll see you, I'll see your screen, and as soon as you're done, you turn everything in just like you usually would on a my CCA assessment, and then you'll be able to leave the Google Hangout as soon as you're done. Okay, so I hope that's clear, and you can always send me a message if it's not clear, and I'll be putting announcements out just to make sure that you guys make it in time for the test. Okay, with that being said, just quickly going over it, date of the test, you will log on to the Hangout, you will go onto my CCA, you'll take the assessment, you'll be working on it independently, and then once you hand it in, you can leave the Hangout. That's pretty much it. Okay, so let's get into the test. Now, most of the test is going to be simple questions, just like on this worksheet. Now, obviously, there can be word problems, and I can tell you different things in different ways and all that kind of deal, but the basic idea of Module 13 is, can you find the volume of a cylinder? Can you find the volume of a cone? Can you find the volume of a sphere? And as we know, in order to find those volumes, we just have to really know the equations and how to work with them. So let's start with that. Okay, so let's take a look at number 1 here. And just before I go into it, you can see all the answers are here. And I'm going to be asking for your answers in terms of pi as well. I'm not going to make you spend a bunch of time doing arithmetic. I believe that you can do the arithmetic, and I don't want to knock you a bunch of points if you get the arithmetic wrong. You're going to have to simplify your answer if it's a fraction. But I'm going to ask you to just keep your answer in simplest form and in terms of pi, just like the answers are in this worksheet. So you're not going to be approximating for pi 3.14. In fact, really, as a mathematician, you don't want to approximate anything if you can avoid it, because guess what? It's an approximation. It's not an exact answer. Where if we leave it in terms of pi, then we at least leave it as an exact answer. So open my sketchbook program and let's get started. All right, so if we've got a cylinder here, then the first thing that we have to do is talk about the volume of a cylinder. Well, the volume of a cylinder is equal to pi r squared h. Simple as that. So this is our radius here, 5 feet, and this is the height here, 8 feet. Cool. All right, so let's write that down. One of the best practices when you're using a formula like this is to write down what you have. So the radius is 5 feet, the height is 8 feet. And the last thing that's kind of good to know is, what am I looking for? That's what I'm looking for. V equals what? I'm looking for the volume. Okay, cool. So I've got my volume, pi r squared, so it's 5 squared times height is 8. So that's pi times 5 squared is 25 times 8. Okay, and if you have to do the multiplication the long way, go ahead. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. So this comes out to the volume of the cylinder being 200 pi. And now remember your units. It's feet cubed. Okay, and that's it. You got the volume. Simple as that. Cool. All right. It's a video, so I'm not going to pause and go back through everything. You can pause and rewind and go back through it again. Here we go. Volume of a cone. How do we find this? Well, first we start with the volume of a cone, the formula. Remember, it's 1/3 pi r squared h. So it's the same thing as the volume of a cylinder, but with this 1/3 added to the front. All right, so what's the radius? Which one is it? That's the radius. And this right here is the height. Okay, so the volume of the cone is 1/3 pi. R is 10 centimeters squared times h is 20. Okay, so I get 1/3 pi. 10 squared is 100 times 20. 20 times 100 is 2,000. So I end up with 2,000 over 3 pi centimeters squared. So 2,000 over 3. Now, if remember the trick for 3 to see if it's divisible by 3 is I add up all the digits. 2 is plus 0 plus 0 plus 0 is just 2. 2 is not divisible by 3, so I can't simplify this fraction at all. So I can just leave it there. 2,000 over 3 pi centimeters squared. That's an exact answer. Now, could you turn this into an improper fraction? Yes, you could. But I'm sorry, could you turn it into a mixed number? Yes, you could. This is an improper fraction, but it's good enough for me. There is another way that you could write this if you so choose. You could call this 2,000 pi over 3 centimeters squared, but generally speaking, this is not the way to do it. That's the better way to do it, because this is some number multiplying it by pi, which is an irrational number, times centimeters squared. So that's how I'd like to see your answer, as an improper fraction by pi. Could you turn this into a mixed number if you'd like? Yes, and then you'd have to do 2,000 over 3, and then that goes 6 times 18, and it's going to be 6 and repeating, and you'll get some mixed number, 666. Ooh, that's a fun number to start with. 666 and 2/3 pi centimeters squared, but I don't want to bother with that. I don't care about making it a mixed number. I just want the answer. So there you go. Done. All right, next. 3. Number 3 is a sphere. And in this case, they don't give us the radius, they give us the diameter, so we're going to have to deal with that. So the first thing that we want to talk about is the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. There's no height in this situation, but we can still get our volume as long as we know our radius, but we don't know our radius. This case, we have our diameter. Diameter equals 16 yards. Well, fortunately, we know that radius is just the diameter over 2. So it's 16 yards over 2, which is 8 yards. So once we have our radius, we just plug it in there, and we get the volume equals 4/3 pi r cubed. R is 8 cubed. Okay, so what does it mean when you cube something? It means you multiply it by itself 3 times, or twice rather. 8 times 8 is 64. Multiply it again. 8 times 64 is 512. You can do the math if you'd like. But yeah, 4/3 pi times 512. Okay, we're going to see 5 plus 1 is 6, plus 2 is 8. That's not divisible by 3, so 512 is not divisible by 3. If it was, I'd be able to eliminate that part of the fraction, but I can't. So instead, I just multiply 512 by 4, and I get 2,048 over 3 pi. And what are my units? Yards. So I don't forget my units. Cubic yards or yards cubed. That's it. You're good. And listen, could I make you do the arithmetic here? Yes, and I'd have you do 2,048 divided by 3, and that wouldn't be fun, and then multiply it by pi, and that wouldn't be fun either, 3.14, or I'd say 2,048 and multiply it by 3.14, and then divide that by 3, and none of that would be fun. I guess it would be fun, depending upon what you like to do with your spare time, but the point is, I don't want you to do that. What I want you to see is that you know how to use these formulas, and you can get the answer. The rest is just what you can do in a calculator, so I'm happy with this as your final answer. Now, how can I make this harder? What could I do? Well, let's take a look at this one again here. Let's use these same numbers, but let's pretend we didn't, okay? Just calculating the volume again, it's going to be pi, oh yeah, 200 pi, I remember. So let's say instead of giving you everything, I just say that the volume is 200 pi cubic feet. Let's say that's what I give you, but I don't tell you the height. You're like, what? How do I do this? Well, and then I say to you, find the height of the cylinder. You're like, what do you mean? I can't find the height. All I have is the formula for the volume. Well, use what you got. So the volume of a cylinder is pi r squared h. Well, I know the volume. It's 200 pi. And I know radius is 5. I don't know h. Well, all I have to do is isolate it, and then I'm good. So 200 pi equals pi. 5 squared is 25 h. I divide both sides by pi. The pi cancels. I get 200 equals 25h. I divide both sides by 25. And I get h equals 8 feet. And I'm done. Cool. So I found the height. You see, this is kind of using the formula to solve for something else. And in fact, if I wanted to, I could just rearrange this whole formula and just by dividing by pi r squared and say the height of a cylinder is equal to the volume of the cylinder over pi r squared. And then all I'd have to do is just plug in the numbers directly and solve. But effectively, that's doing the same thing. Okay, so I can use this formula to solve for V, R, or H, depending upon what I'm given. If I'm given V and R, I can solve for H. If I'm given V and H, I can solve for R. If I'm given R and H, I can solve for V. It just depends upon what you want to solve for and what you're given. All right, so let's try this again now, but instead, let's say I know my volume again is 200 pi feet cubed. And again, you wouldn't be given all this and the volume. You'd be given something more like this, right? Where it just says, okay, the volume is 200 feet cubed. And what's the radius? That's r. Okay, so your height, you know, is 8 feet. But you want to solve for r. So r equals what? Okay, well, just use my formula. V equals pi r squared h. H is 8. V is 200 pi. So I get 200 pi equals pi r squared. I don't have r. H is 8. All right, cool. Well, let's figure this out. Again, I divide both sides by pi. And I get 200 equals 8r squared. Then I divide both sides by 8. And I'm going to get r squared equals 25. Cool. Well, what do I do now? I don't have r. I have r squared. Well, if I want to solve for r, what do I have to do? Take the square root of both sides. Very good. All right, so I'm going to take the square root of both sides. And I get r equals 5 feet, which I already knew from before, so I know that's the right answer. Okay, so cool. I'm good. So that's how I can solve for r. The only difference here is that I have to end up taking the square root of both sides. Okay, so it's a little bit more challenging because of that square root element to the question. All right, and the same thing is true for cones. So let's take a look at cones. Let's use this one. But I think I'm gonna switch up the numbers a little bit to make them nice. So here it was 20, but I'm gonna make that 30, right? So if I solved for the volume here, it would be 1/3 pi, oops, I don't want the eraser, I want the pen, pi r squared h. So it would be 1/3 pi, r is 10 squared times 30. It's going to end up being 3,000 times 1/3 will be 1,000 pi. Okay, so I just showed you that the volume here is 1,000 pi, but now remember I changed this from the original height. So let's say now I don't give you the height. I just tell you that height is h and the volume is 1,000 pi centimeters cubed. Well, I know my radius is 10 centimeters, but the question is, what's the height? That's the question. Well, again, I have to go back to my formula. okay? So it's 1/3 pi r squared h. So again, I just use this formula in a different way. I just isolate h. So my volume is 1,000 pi equals 1/3 pi r squared. Oh, but I have r, sorry. So let's make that 10 squared h. So, okay, let's simplify this first. 1,000 pi equals 1/3 pi times 10 squared is 100 h. Okay. Now, what do I do? Well, there's a lot of ways to handle this. I'm going to just go forward and just move this 100 times 1. So I'm going to make that 100 over 3 pi h, and that just looks a little cleaner to me. And it's going to be easier to just work with because we just have one fraction to deal with rather than this fraction and this whole number. So the first thing I'm going to do is the same as always. I'm just going to get rid of pi. Okay, this is another reason why it's nice to keep your volume in terms of pi. Okay, because then I can eliminate it easily. If I had this volume as an approximation as multiplied by 3.14, this would end up being 3,140. And then when I divide by pi, I'm going to get some crazy decimal. But here, when I divide by pi, since I left my volume in terms of pi, I just get 1,000. So I get 1,000 equals 100 over 3h. Cool. Well, to get rid of this fraction, as you know, I just multiply by the reciprocal. Okay, and that cancels and that cancels. I'm left with just h here. 1,000 over 100 is 10. 10 times 3 is 30, which I set the height as 30 earlier, so I know that's the correct answer. Cool. So same deal. I just have to isolate. In this sense, I have a fraction. In this case, I have this like 100 over 3, so I have to multiply by the reciprocal, but everything else is the same. Okay, let's do it again, but instead, let's solve for the radius. So again, I'm going to make this 30 centimeters, and I'm doing that just to make my numbers easier to deal with, but they don't have to be perfect. It just, when I'm explaining it to you, I like to have easy numbers. Okay, so now I tell you that the volume is 1,000 pi centimeters cubed. I tell you that the height is 30 centimeters, and then I ask you what is the radius, and that's up to you to solve. So I get v equals 1/3 pi r squared h. Okay, well my v is 1,000 pi. 1/3 pi r squared. R squared, I don't know what r is, so I just leave that as r squared. And h I know is 30. Okay, cool. So let's simplify. I get 1,000 pi equals 30 divided by 3 is just 10. Ah, that's nice. So this just becomes 10 pi r squared. So I'm just going to go ahead and divide by 10 pi all in one step. That's legal. I can do that. This cancels, that cancels, this cancels. I'm left with 1,000 over 10 is 100 equals r squared. Again, I don't have r. I have r squared. Don't be fooled. Don't say r is 100. You have to do something. What do you have to do? Take the square root of both sides. Good. All right. So square root both sides. I end up with r equals 10 centimeters. Good. Now, one caveat here. Usually when I have something squared, like if I just told you x squared equals 144, if you took the square root, you'd have to do plus or minus, and you'd get x equals plus or minus 12. And why is that? Well, because if I did 12 squared, that's equal to 144. But also, if I did negative 12 squared, well, that's just equal to negative 12 times negative 12. And I know a negative times a negative is a positive, and 12 times 12 is 144. So usually when I take the square root like this, where I have x squared equals 144, I have to consider both the positive and the negative square root. That's why it's plus or minus. But in this case, I don't have to consider the negative. Why? Well, because it wouldn't make sense for your radius to be negative 10 centimeters. That's not a physical reality that I'm concerned about. So the radius is only considering that positive square root. And that's pretty much it. So finding the height, finding the radius of both the cylinder and the cone, and I'm pretty good. Now, the sphere. The sphere is a little bit different here. So let's take a look at it. Are there any ones where they show radius? Yeah, okay. So boom, number 20. So let's say number 20, I don't give you the radius. I just say this is r, and I leave it up to you. But I tell you that the volume is, let's say it's 36 pi, I don't know, inches cubed, let's say, okay? So it's 36 pi inches cubed. All right, well, how do I deal with this? How do I deal with this? And I say solve for the radius. And the question is, how do I deal with this? How do I solve for the radius? Well, I have to start with my formula, just as always. 4/3 pi r cubed is the volume. Well, I know my volume is 36 pi, but I don't know my radius. That's okay though, because that's the only variable that I have left. I only have two variables in the volume of the sphere, so all I need is one of them to solve for the other. I can use the radius to solve for the volume. I can also use the volume to solve for the radius. It's just a little bit different. So now, how do we deal with this? First, let's get rid of this pi to make our lives a little bit cleaner and easier. So I get 36 equals 4/3 r cubed. Again, I want to get rid of this fraction, so to multiply by the reciprocal. That's how I do it. Boom, boom, that cancels out. 36 divided by 4 is 9, times 3 is 27. I could also do 36 times 3 is 108, divided by 4 is 27, but dividing is easier in this case to do first. So now I end up with r cubed is 27. Now, I don't want to take the square root of both sides because that doesn't make sense, because it's not r squared is 27, it's r cubed is 27, so I don't take the square root, I take the cube root. What's the deal here with the cube root? Well, I have to put a 3 there. Okay, so usually when I take the square root of something, it's like 1 square root of 144 is 12. I could put a 2 here, but since people do the square root so often, they just say, okay, forget the 2. If you just leave the symbol without the 2, then I know that you're talking about square root. But any other root, like the cube root, you got to put that number there to let people know what kind of root you're taking. So that cube root cancels out here, and that's r. But the question is, what's the cube root of 27? Well, the answer is simple. If I take the square root of 16, I know that's 4. Why? Because if I take 4 and square it, I get 16. So the square root is the inverse operation to the square, right? The square root of 16 is 4, whereas 4 squared is 16. Okay, cool. So to find the cube root, I have to do the inverse of a cube, which means I have to find the number that when I cube it, I get 27. So what is that? Well, 2, let's see, 2 times 2 is 4 times 2 is 8, so that's not it. What about 4? 4 times 4 is 16. 16 times 4 is 64, so that's not it. What about 3? 3 times 3, let's see this, 3 times 3 is 9. Multiply that by 3 again, you get 27. Or in other words, 3 times 3 times 3 is 27. Or in even better words, 3 cubed is 27. Cool, so 3 cubed equals 27, then the cube root of 27 is 3. And how do I prove that? Question is, how do I prove that? Well, let's take a look. If I were to take the cube root here of 27 and the cube root of this side as well, that cube root is going to cancel. I'm going to be left with 3. And in other words, 3 is the cube root of 27. Cool. So cube root of 27 is r, so r equals 3. And I'm done. So that's pretty much it. I mean, beyond this, you are going to be expected in the test to be able to do some higher order thinking skills. So expect to find 1 or 2 questions that aren't going to be exactly obvious. You know, it's not going to be so simple as just finding the volume or finding the radius or finding the height. Expect there to be some questions that you're really going to have to think. But even more than that, expect questions that are going to be word problems, and you're going to have to determine, okay, what shape am I finding the volume of? And if I find the volume of that shape, what's the radius, what's the height, and things like that, and you're going to have to determine that. Also, if you're given the diameter, things like that. So you're going to have to work through word problems and make sure that you understand those. And there are plenty of examples of those in the book, and those can be helpful to you. And I definitely recommend you look through all the higher order thinking skills, and you've done a lot of problems like that in your homework already as well. So with that being said, make sure you study. This review video is specifically just meant to help you go through the basics. It doesn't mean every single problem is in this review video, so you're definitely going to have to do more studying than just watching this video. But with that being said, this is about 60-something% of the test. So if you've got this mastered and you got it down, expect yourself to at least pass the test. But obviously, you want to do much better than that. So watch the other videos, go through your book and look at higher order thinking questions, and just make sure you understand Module 13 in general. Okay, what's volume? What are we doing here? Volume of cylinders, cones, and spheres. That's pretty much it. With that being said, that is it for me for now. Until next time, enjoy mathematics.